Hello, today we are doing the 7.3 notes, which is reference angles and degrees and radians. So this is a review of a previous math class in pre-cal, but we're gonna go through it as if it isn't a review and maybe just a tiny bit faster. So an angle in standard position is this guy right here. So you always start at 0. So right here, even though it says 360, 0, and then one whole trip around the circle is 360. So if one whole trip around is 360, half is 180, a fourth is 90. So basically these count by 90s, or I like to do 9s and then add a 0. So 9, 18, 27, 36, and you can actually keep going around forever. So there's an infinite number of angles. If it's a positive angle, we are going to go up, so we are going to go counterclockwise, so we go up this way. If it's a positive angle, and if it's a negative angle, we're going to go down. Okay, so that's the first part. So we are starting with drawing our angle. So draw a 60-degree angle. Well, if this is 0 degrees and this is 90 degrees, then 60 degrees is about 2/3 of the way, right? So 30, 60, 90. So try and get it pretty close. It doesn't have to be perfect, but this right here would be a 60-degree angle. Okay, 225. Okay, so 225 is between 180 and the 270-degree mark, and more specifically, it is halfway in between, because 180 plus 45 is 225, and then 225 to 270 is also 45. So this angle starts at 0, and you see up here this actually had the arrow to start. You can do that on all of these, but you know, mathematicians are lazy, so since we always start at 0, a lot of times you won't see them write that little starting piece, but you'll have this rotation, and then it's going to bisect that right there, and that whole rotation is a rotation of 225 degrees. Next one is negative 100. Negative angles go down. So this is just going to be negative 90, and this is negative 180. So I'm only 10 degrees past, so it's just that little slight angle right there. But you can see which direction I went based upon how I either curved up or I curved down. Last one is 390 degrees. So we have 0, 90, 180, 270, 360, and then we can do this infinitely. This would be 450, and I can do that quickly because I just do my 9s. So 0, 9, 18, 27, 36, and 45, and then I just add the 0. So 390 is 30 degrees past. So it's just going to be a little baby angle right there. And actually when I draw it, I should be drawing it like this to show that I took a loop around the circle. Okay, next we're going to move on to the definition of reference angles. Reference angles are acute angles that connect your angle to the x-axis. Okay. So your ray and the x-axis are what make the reference angle. The reference angle is always positive, so it's super important that we get it back to the x-axis and that it's always positive. Acute angle means that it's less than 90 degrees because it's acute, it's a baby angle. So right here, this angle that I have graphed here started at 0 and it came around to 300 degrees. To find the reference angle, I'm going to take this line that's connected to the origin, and I'm going to connect it always back to the x-axis, and the reference angle, which we call theta prime, is that angle right in there. So from 270 to 300, this angle would be 30 degrees. And if that angle is 30 degrees and every quadrant adds up to 90 degrees, because they're right angles, that would mean that my angle right there, theta prime, has to be 60 degrees. and it's less than 90, and it's positive. So again, this little sliver from 270 to 300 is 30. How am I going to get from 300 to 360? I would have to have an angle of 60 degrees. All right, this next one right here, this angle started at 0 and it came all the way around to 145 degrees. I connect that piece to the x-axis, and the angle I'm always interested in is the one that kind of comes from the origin and the x-axis. So this is at 145. How much more is it going to take me to get to 180? If you're not sure, just use your calculator. 180 minus 145 is 35 degrees. Not a special ratio, a special triangle ratio, but it's not asking for those, so 35 degrees is fine. This guy comes all the way around in here. You're always connecting to the x-axis. So you see these lines? I'm always drawing them up or down. I should never ever draw a line sideways. I'm always connecting to the x-axis, so it's either up or down. So what is this little angle in here made by these two sides? It's hard because my hands are in the way. That angle. I want that one. So 180 to 225 would be 45 degrees. And the notation for a reference angle is theta prime or theta apostrophe, and that's just saying, hey, it's related to theta, but it's not exactly theta. It's the angle that gets us back to the x-axis. Okay, so the next example asks us to make a sketch and then identify the reference angle, so we're taking it one step further. So for this one, we're going to graph 150 degrees. So that's between 90 and 180, and it's all the way to here. So that right there is 150 degrees. I connect it to the x-axis, and this is the reference angle right there. So if this piece was 150, to get back to the x-axis, I would need another 30 degrees. Okay, next one is 60 degrees. So I'm going to draw my 60 degree angle. That's this guy right here. That's 60 degrees. And then, I already did it, but I'm going to connect it back to the x-axis right there. I'm going to draw that in. Sorry. It's going to drive me crazy. I like consistency. Okay, so there's my 60 degree angle. Whoa. Well, and then I'm connecting it back to the x-axis. So whenever you're in quadrant 1, your reference angle and your actual angle are always the same, because in quadrant 1 every angle is an acute angle, so therefore it has to be a reference angle. Alrighty, 135. So I graph 135 degrees. So first I have to figure out it's in quadrant 2, and it's bisecting quadrant 2 because 90 plus 45 is 135. So it goes like this and bisects it, cuts it in half, drop it down with the x-axis. The reference angle is that guy right there. And we already know I went 45 degrees past, so I have to go another 45 degrees to get to the x-axis, because with reference angles, we always got to get to the x-axis. 210 is between 180 and 270, and it is 30 degrees past, so it's just a tiny little 1/3 of the way sliver. So there is 210 degrees. Connect it to the x-axis, and I'm interested in that angle right there. Okay, so that's theta prime in there, and I had to go from 180 to 210, which would be 30 degrees. Moving on up, negative 30 degrees. Alright, no problem, Bob. Negative 30 just means we go down negative 30 degrees. So instead of going up, we're going actually clockwise. And then I connect it to the x-axis. And my reference angle is this guy right in here. And that angle is always positive. So even though I went in a negative direction, the reference angle will always be positive. So it's 30 degrees. Negative 300. That's going to be between negative 270 and negative 360. So I'm going to go like this, negative 300. So negative 270, this angle right in here is 30 degrees because that's negative 270 and the terminal side is ending up at negative 300. So what I want to know is this angle right in there. And if that was 30 and the whole quadrant always equals 90, then that's going to be a 60-degree reference angle. And again, reference angles are always positive. Negative 390, so we have one that's bigger, so it's going to come all the way around. That's negative 360, and then this is negative 450 down here. And so it's going to go to negative 390, which is right here. Connect it to the x-axis, again going up or down. I want that angle right in there. I had to go 30 degrees past negative 360 to get to negative 390. So that must mean that that's a reference angle of 30 degrees. Negative 495. Ooh, okay. Negative 360, right? And negative 450. Or negative 45, add the 0, and then the next one is negative 54, add the 0. So how much past 450 is this? It looks like it's going to bisect. And these ones are rigged. A lot of them are bisecting or doing 30, 60, 90 triangles because these are the ones that we can evaluate without a calculator. So they're kind of rigged. Are they always that way? No, but when you're first learning stuff, it's more helpful if we do it like that. Okay, so now what we're going to work on is the other type of measurement. So in math, we can measure angles and things in degrees, but more commonly to mathematicians, we actually measure things in radians. The official definition of a radian is when the angle made by the center arc is equal to the length of the radius of the circle. I'm not going to quiz you on that, but I do need you guys to just be aware that there is an official definition. We are now going to learn how to convert from something in degrees to something that is in radians. And the way that we can do this is by looking at this right here. So if we are on the unit circle, the radius is 1. We've already talked about this. Or we will anyways. So if we know that the radius is 1 on the unit circle, which we might actually be getting into more detail in the next lesson, but that's okay. Unit circle like 1 unit because its radius is 1. Then we look at the circumference, and the circumference formula is 2 pi r, and when we plug in the unit circle radius of 1, we just get the circumference is 2 pi. So one whole trip around the perimeter of the circle is 2 pi, but that's also 360 degrees, right? And so if one whole trip around the circle is 2 pi, then when I go halfway around the circle, it's just going to be pi, which is also 180 degrees. So when we need to convert between degrees and radians, the way we do it is we are going to take the degree, so 180 degrees or whatever, and multiply it by the ratio that says pi over 180 are the same. We want to make sure that if we're starting in degrees here, that we have the degrees in the denominator, because then the units cancel out. It's stoichiometry from chemistry, making sure those units cancel out. And if we start in radians, then what we're going to do is times it by the reciprocal of that one, which is 180 over pi radians, and then those will cancel as well because the radian unit and the radian pi will cancel. I do want to point out as well that we could also have done radians, or degrees for that matter, being 360 over 2 pi, because those are also equivalent, but mathematicians aren't going to leave an unreduced fraction. So that's why they do 180 over pi, or in that case, pi over 180. All right. So this one right here says convert each angle from degrees to radians. So whenever I do these, I just set up a chart like this. And you're going to multiply within this chart. So I'm trying to get rid of the degree symbol. So I'm going to put 180 degrees and say that's equivalent to pi. The degree symbols will cancel. And then I have 30 over 180 times that pi. So 30 over 180 times pi. And in your calculator, if you do, ignore the pi when you're doing your calculator, otherwise it's going to mess you up. If you do 30 over 80 and hit enter, and then do math, enter, enter, it'll tell you that that's 1/6. So this is 1/6 of pi, but again, mathematicians like to write things in the shortest form available, so this one they'd actually write as pi over 6, because 1 times pi is pi, and 6 times 1 is 6. Negative 245, so I'm going to do this without my little chart. I'm going to times this by pi over 180. The degree symbols will cancel out, and then into my calculator I do negative 245 divided by 180. I get a fraction, and then I hit math, enter, enter, and that fraction is negative 49 over 36, but I still have that pi, so negative 49 pi over 36. I'm not calculating a reference angle, so it's okay for it to be negative. All I'm calculating is the angle in radians. So it's the same thing. It's like converting from Spanish to English. Like, it's the same number, it's just in a different form. 225, I'm going to multiply that by pi over 180. Again, the 180 is staying in the denominator because I'm trying to convert to radians. Whoops. So 225 divided by 180. Oh, whoa. 225 divided by 180 equals, math, enter, enter, 5 over 4. So then I just need to put the pi in the numerator. So that's 5 pi over 4. Okay, now we're going the opposite way. So we're going to convert from radians to degrees. So in this case, because I want to end up with degrees, I'm going to put that in the numerator. And then I am going to cancel out the pi's. So I get negative 4 times 180 degrees divided by 3. So in my calculator, negative 4 times 180 and then divided by 3. And that gives me negative 240 degrees. Now this one says 5 pi over 12, so I'm going to do 180 degrees divided by pi. These cancel, so I have 5 times 180 divided by 12. $75 degrees. And then next is pi over 4. Again, anytime I'm trying to convert, whatever unit this is, I want to make sure that that's the unit in the denominator so that they cancel out. So this one I just have 180 degrees divided by 4, which equals 45 degrees. Okay, evaluate the following trigonometric functions with a calculator. Round answers to 4 decimal places. Remember to change the mode of your calculator. Okay, so this is the way it works. If you see a degree symbol, it's in degrees. If you don't, it's in radians. So sometimes there's a pi and sometimes there isn't. That doesn't matter. If you see the degree symbol, you should be in degrees. Otherwise, default mode is radians. So I'm going to go through and write radians, 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 degrees, degrees, radians, degrees, and degrees. Okay? In our calculator, there's a mode button right here. So I'm going to hit mode, and then I'm going to do my radians first, so I need to switch to radian mode. So I'm going to do the tangent, and notice the parenthesis of pi. There's a pi button, it's right below the clear button. You have to hit second, and then pi, and then divided by 7. And then 4 decimal places, I actually have to look to the 5th one to see if I need to round that, and I do, so 0.4816. I'm going to skip B because that one's in degrees, and then I go to this one right here which says cosecant of pi over 9. Now, cosecant button is not on your calculator. This inverse sine button, sine to the -1, is not cosecant. So what we're actually going to do is take the reciprocal of sine. So if we put it over 1, that gives us the reciprocal. So I'm going to do 1 divided by the sine of pi divided by 9. And I get 2.9238. Okay, next one, secant. There's not a secant button, but I know its reciprocal is cosine. So I'm just going to put 1 over the cosine as another way to write secant. And I get that the cosecant of -2 pi over 3 is actually just -2. And I guess because they said 4 decimal places, I should probably do that. I won't mark you wrong on the test if you don't do that. The only other one that's in radians is the sine of 4 pi divided by 5, which is 0.5878. Don't have to do reciprocal because there's actually a button on the calculator. Alright, for the rest of these I gotta go change my mode to degrees. So mode degrees. And then we're just gonna go through these. Cosine of 135 equals -0.7071. Okay, sine of 55, still in degree mode, so we're good to go. So we get 0.8192. Some of you weren't doing a great job at your rounding. No, never. So make sure that you are looking at that carefully. We have to go to the 5th decimal place to make sure we round the 4th one properly. So 0.8192. And then secant of 315, no secant button, so I do 1 over the cosine, because there's only one SC per pairing. Cosine of 315. And this one's going to be 1 over the tangent of 76 degrees. (1.4142). And then 1 divided by the tangent of 76 is 0.2493. Okay, so those were the calculator problems. And now we are going to be sketching angles in radians and then finding the reference angle. So this takes a little bit of practice. I'm not going to go super fast, but you can always pause it so that you can get it down. Okay. So first thing we have to do is sketch 3 pi over 4. I am not going to convert that to degrees for you because we use radians so much more in math. You have to get comfortable with it. At first it's super uncomfortable because it's new, but you'll get it. Everybody always gets it. Okay, so we know that this is 0, but we also know that it's 2 pi. And if we know that this is 2 pi going all the way around the circle, then this is pi. Okay? What we're going to do to make our life easier is whatever the denominator is, we're going to make this 4 out of 4 pi. That's still pi because 4 divided by 4. So this is only saying 3 out of 4 instead of 4 out of 4. So if I were to cut the top half of this coordinate system, there's 1 piece of pizza, 2 pieces of pizza, 3 equal pieces of pizza, and then the 4th one. But this says only go to the 3rd one. So this one is actually pi over 4. This is 2 pi over 4, which is pi over 2, and then 3 pi over 4. So this right here is 3 pi over 4. So if this is 3/4 and you have a whole fraction right here, this itty bitty bit is our reference angle right here, and that's going to be 1/4. But we're in units of radians, so it's going to be 1/4 of pi, or pi over 4. Okay, next one, pi over 6. Okay, here's 0, here's pi, right? We're going to make this 6 out of 6 pi since that's my denominator. So what that tells me is I'm going to take the top half and cut it into 6 equal slices. So there's 1, 2, 3. Here's the 3rd one. 4, 5, and 6. Approximately equal pieces. Don't judge. So 1/6 is here, 2/6, which is actually pi over 3, 3/6, 4/6, 5/6, 6/6. This is only asking for 1/6. And then I drop it to the x-axis to find my reference angle. So because it's in quadrant 1, the reference angle is always the angle, so that's just pi over 6. Okay, now we're starting to progress. 5 pi over 4. No big deal. So this is 4 pi out of 4. If this is 4 out of 4, then this over here is 8 out of 4, because remember, aka this is also known as 2 pi. But the reason why I'm choosing to write it is 8 pi over 4 is to help me graph this. So let me show you what I mean. If I cut my whole thing, this is 1 pi over 4, 2, 3, 4 out of 4, but now I have something bigger than 4 out of 4, so the bottom half now has to get cut in half, or cut into fourths. So this right here is 5 pi over 4. Okay, so that's the angle that I want, because there's 1 pizza, 2, 3, 4, 5 slices. Drop it to the x-axis, and then you just need this little sliver. Well, how much of a sliver is that? Super easy. That sliver is pi over 4. So then I have students who make the connection that whatever your denominator is, that's usually going to be your reference angle. It's not always that way, but these problems are all rigged, so for you, it will be. 4 pi over 3 says this should be 3 pi over 3. So it's kind of hard to divide it into 3 when you already have this here, so I'm going to temporarily erase this for you to show you 3 equal pieces. So there's 1 pizza slice, 2, 3. And then this says 4 pi out of 3, so I actually have to keep going. So I'm only looking at the pink pieces right now. So here is 1, 2, 3, and then 4. So this right here is 4 pi over 3. I'm going to drop that to the x-axis, and then this is theta prime right in there. So if that's theta prime, this was 1, 2, 3, that's only 1/3. So theta prime is pi over 3. And remember, they're always positive no matter what. Okay, next one is 11 pi over 3. Ooh, these are getting tricky. Okay, so I'm going to draw this. Make this 3 pi over 3. This guy is going to be 6 pi over 3. Let's go back again. Isn't this also 9 pi over 3? And this guy's 12 pi over 3? Because that would be 4 pi. So this is what's happening. Let me draw in my thirds real quick. And I'm erasing these because I really want you guys to see the thirds. Sorry, I can't help it. Okay, so here we go. We're starting at 0. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7, 8, 9, 10, 11. So this is where 11 pi over 3 ends up, is right there in quadrant 4. Let me go ahead and put these guys back in there just so it's a little more visual for you. And then this is my reference angle. If this is 11 pi over 3, what is that guy right there? Pi over 3. Great job. So you get really fast at these after a while. It just takes practice. But don't stress if you are not getting it. I see this as another pi over 3 one, so just gonna ignore that because it messes me up when I'm trying to do thirds, because thirds isn't in halves. Okay, so now I'm just counting. This is 3 pi out of 3, so this is 1, 2, 3, 4, 5, 6. Okay, 7, 8, 9, 10, 11, 12. Ooh, this is going to be fun. Then we have 13 and 14. Look at that spiral. That's crazy. So that goes all the way to there. And again, this is to draw. It doesn't just say to find your reference angle, so you do need to have those. But we do already know that our reference angle is going to be pi over 3 because that's what's going to always get us back to the x-axis. Negative 2 pi over 3. Not even going to draw my, let's pretend that's the center. Okay, not drawing my x-axis or my y-axis. I'll draw it right there anyways, just for fun. Negative 2 pi over 3 just says we go this way. So there's negative 1 pi over 3 and negative 2 pi over 3. We connect back to the x-axis, which is right there. And then theta prime is that angle. So if this was 2 pi out of 3, and then this right here is negative 3 pi over 3, we're just going to be very, very good about making sure that we never make our reference angles negative. Even if the angle that we're given is negative, reference angles are never negative. So that's pi over 3. And last one is negative 11 pi over 6. So I'm going to split everything into 6 equal pieces, which is the same thing as 30 degrees. Because 180 divided by 6 is 30 degrees. And I got negative 11 pi over 6. So 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11. That right there is negative 11 pi over 6. Make my x-axis. That in there is theta prime. And theta prime is going to be equal to just pi over 6 because it's only 1/6 of a sliver. And that's it.